So today we are going to simplify square roots, and you've probably seen this before, but hopefully the explanation I give is going to make sense to you, where a lot of confusion exists. So if I take the square root of 4, I get a whole number. But if I take this, say, the square root of 12, I don't. The square root of 12 is going to be 3.46, and it goes on forever. Okay? This is sort of similar to how some fractions turn out to be whole numbers and others don't. So if I had 40 over 8, what is that? What is 40 divided by 8? 5. But what about 24 divided by 8? Oh, wait, that one works. Sorry. Let's do 28 divided by 8. Put the phone away, King. Are they good looking? No? That wasn't worth it. So, does 28 divided by 8 come out evenly? No, it doesn't. It's going to be 3.5. However, can I simplify 28 divided by 8? Yeah. I could take, say, a 4 out of each of those. So 4 times 7 over 4 times 2. Does that make sense? So 28 is 4 times 7, 8 is 4 times 2, and what is 4 divided by 4? It's just 1, so this becomes 7 over 2. So sometimes fractions don't simplify, or sorry, sometimes they don't come out evenly, and yet they still simplify. Oh, do the assignments you're missing? Yeah, you can. Well, yeah, just go back to the, so you have to do the modules in order. Okay, sorry for the interruption. So, 28 divided by 8 does not come out evenly, but it still does simplify. How many different ways are there to write a fraction equivalent to 7 over 2? Well, 28 over 8 is another way. Can you think of another fraction that's equal to 7 over 2? 14 over 4. How many are there? An infinite number. So, because there are an infinite number of equivalent fractions, we have decided in mathematics that whenever you see a fraction, simplify it. That way, everybody gets the same answer. Okay? Well, the same sort of thing happens with square roots. There are an infinite number of ways to write the square root of 12. Okay? So we need a way to simplify them so everybody gets the same value. And what we're going to do is pull out what we call the perfect squares. So the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of, what's the next one? 25 is 5, the square root of 36 is 6. But I want to show you something about these that maybe you've never thought of. Why does 4 square root? Because it is 2 times 2. Right? So the square root is asking what number times itself is 4? And the answer is 2. So 9 is the square root of 3 times 3, right? And 36 is the square root of 6 times 6. But we can also write 36 as the square root of 2 times 2 times 3 times 3. Right? So if I take 36 and I factor it, 6 and 6, and I factor that, and I get 2 and 3 and 2 and 3, and then I just rearrange those, I get the square root of 2 times 2 times 3 times 3. Well, what is 2 times 2? 4. And what is 3 times 3? 9. So this is the square root of 4 times the square root of 9. And that's why 36 square roots, because it has 2 2's and 2 3's. So we can use this to simplify square roots. Anytime you factor a number down into its prime factorization, and you look for numbers that are duplicated, you can square root those duplicates and bring them to the outside. So let's look at 12. What goes into 12? 2 and 6. What goes into 6? 3 and 2. And I'm going to erase anything that factored. So this is called the prime factorization. When you take a number and you factor it down until you're left with only prime factors, that list of numbers is going to be unique for every number you factor. There is only one way to break down a 12. You end up with 2 2's and a 3. Okay? And every other number has its own unique prime factorization. So I'm looking for duplicates. What duplicates do I have? I have a set of 2's and a 3. So I'm going to do this the long way, so hopefully it makes sense. I get the square root of 2 times 2 and the square root of 3. Right? The square root of 12 is equal to the square root of 2 times 2 times the square root of 3. Well, what is 2 times 2? 4. And what's the square root of 4? 2. So this becomes a 2, and that does not simplify. So what I'm telling you is this number and that number are the same, and I'll prove it. So if I do the square root of 12, and I get 2 times the square root of 3, they're the same number. So 2 root 3 is the simplified version of the square root of 12. Okay, let's do some more of these. What about the square root of 24? What goes into 24? 2 and 12, 2 and 6, 2 and 3, and then make sure that you cross off everything that factored. I'm looking for pairs, not the fruit. Do I have any pairs? I have a pair of 2's, and then I have a leftover 2 and a leftover 3. Okay? So let's write that out. This pair becomes the square root of 2 times 2, and the leftovers look like that. Does that make sense to everybody? Well, what is the square root of 2 times 2? It's the square root of 4, so 2, and this doesn't simplify and that doesn't simplify. What is 2 times 3? 6. Okay? All right, let's do the square root of 75. And hopefully you understand enough now that we can sort of do a little bit of a shortcut. What goes into 75? 15 and 5. And what goes into 15? 5 and 3. So I cross off those that factored. And I circle my pairs. For every circle, you write that number on the outside. So if I circle a pair of 5's, I write a 5 on the outside. And then square root. Anything that doesn't get circled goes on the inside. 5 root 3. Does that make sense? Have you guys seen this before? Some of you have? Okay. All right, what about the square root of 72? What goes into 72? 6 and 12, 3 and 2, 3 and 4, 2 and 2. And I go through and get rid of everything that factored. What can I circle? A pair of 2s and a pair of 3s. So on the outside, I write a 2 and a 3, which becomes, do we add them or multiply them? Multiply. So the outside is 2 times 3, which is 6. And the inside is a 2. So 6 root 2. Okay. All right. What about the square root of 30? That's 3 and 10, 2 and 5. Erase the 30 and the 10. What can I circle? Nothing. I can't circle anything, so I just move on. The square root of 30 is simplified. It's like asking, you have the number 1/2, simplify it. Well, it's already simplified. It can't go any farther than that. Okay. What if I had the square root of 196? Well, I don't know my multiplication tables up to 196, but I do know one number that goes into 196, 2. So I will take 196 and divide by 2. 2 and 98. Divide by 2. 2 and 49. 49 is 7 times 7. Now I erase those that factored. What can I circle? Circle a set of 2s and a set of 7s. So what's on the outside? 2 times 7 is 14. And what's left on the inside? Nothing. Does that mean there's a 0 on the inside? No, it's actually a 1. Right? Every number has 1 as a factor. We just don't write it down because it doesn't actually do anything. So if everything comes out, then the square root disappears. So the square root of 196 is just 14. What? Yep, 14 squared is 196. What if there's already a number on the outside? What if we have 6 root 120? Well, we factor the 120 just like we did before. So 120, nope, that's not what we wanted. What goes into 120? 12 and 10, 2 and 6, 2 and 5, 3 and 2. And I cross off everything that factored. What can I bring out? A set of 2s. So what's on the outside? A 2 and the 6 that's already there. So this 2 hits the 6 to make a 12. And what's left on the inside? A 3, a 2, and a 5. So 3 times 2 is 6, times 5 is 30. So the answer is 12 root 30. All right, that's it.